So this was the session 9. So today's agenda, we are going to learn third interpolation formula, that is known as a Lagrange's interpolation formula. Now, why this third formula is required? Already you learned the two one, which is Newton's forward and the backward. The reason is the previous interpolations mainly used or mainly preferred only when or they are used only when values of xi are equally spaced. Okay, that means there should be a class interval h, so h should be a constant there. Yes, that only I am explaining, Harsh, that when to use Newton's forward and backward and when to use Lagrange's, that will discuss it today only. Okay, or at the end of the session we'll discuss it. Okay, so it becomes more and more clear that time because you learned everything and you will know what are the differences between them. So see the today's agenda. The first one that we are going to use this Lagrange's formula for interpolating the value. That means we are going to find the function value using the formula here, Lagrange's formula. So just like Newton's forward and backward, that only. So the similar thing we can find an interpolating polynomial also with a Lagrange's formula. So all the three methods have the same agenda there. That means all the three methods can be used to interpolate. That means can be used to find the function value at a given x. So suppose x equal to 2 and we want fx. That is the we can say it is interpolation that way. So we are just predicting the value of a function fx at x equal to a, some a there, given a, that way. And then interpolating polynomial also we can find out. So whenever we are given n pairs of x and y, so maximum degree polynomial that exists is n minus 1. Okay, so generally for n pairs of x and y, for given n pairs of x and y, n minus 1th degree polynomial can represent it, maximum up to that. So sometimes it is a lower degree also, but maximum up to n minus 1th degree, that we already seen there. Come to the formula here, and one of the most important thing that is already highlighted or already given as a heading here, interpolation with unequal intervals. So this is a keyword to use Lagrange's formula. Remember, interpolation with unequal interval. So whenever the values of xi are not equally spaced, they are unequal, generally only one method came there, that is Lagrange's interpolation formula. Okay, so with the help of Lagrange's formula, we can interpolate for unequal spaced data. So suppose we are given say, okay, let I show you the formula and then we'll discuss also. Suppose we are given y equal to fx at x equal to a, b, c and d. Now remember, b minus a or c minus b or d minus c is not a constant, that is not the same. For example, if b minus a is a 10, c minus b can be a 2 only. Okay, that way. So the difference between two successive values of x is not constant. So obviously we should go for Lagrange's formula, and the Lagrange's formula is given like this. It is a very simple formula. This formula can be used for any number of points there. So let I take only two points. Suppose we are given two values. Say x is a and b, and suppose our fx is f of a and f of b. Suppose we are given these two values, say x1 y1 and x2 y2, only two values given. Can you tell me which degree polynomial will get it for it, this data?
2 degree one.
No, not correct.
The 1 degree.
1. So it should be a degree 1. It is a straight line because we are given just two points. When two pairs of x and y given, maximum n minus 1th degree, that is 1th degree polynomial exists, and 1 degree means linear, that is a straight line. So this for the 2 points, yes, straight line can be a best curve which fits that data. Okay, so when we have 2 points, so when we are given 3 points, generally we quadratic polynomial we can fit it there for 3 points, for 3 pairs mainly I am saying. So what is this equation of the straight line now? Equation of the straight line passing through these 2 points now, and that equation of straight line is like fx, that fx is nothing but y equal to, okay, so this is like x minus b upon a minus b into f of a plus x minus a upon b minus a into f of b. If you simplify this, this becomes the equation of a straight line, like y equal to, this is a slope, this part is like slope m, sorry, not that slope, because x terms are there, so you have to simplify that, collect x terms together, and if you simplify you'll get that slope y equal to mx plus c form also. So this way you can get the equation of the curve which fits that the data by a Lagrange's there. This formula is given for 4 points A, B, C, D. Remember, the maximum 4 points will be given in the exam. Definitely not more than 4. It is not possible. Otherwise, this multiplication of x minus a into x minus b into x minus c, that becomes so complicated and lengthy there. Okay. Any doubt in the formula?
No, sir.
Okay. So it is just formula based again, just like forward and backward interpolation. So you will come to know with examples here. So the question number 1 is on the screen now. The question is given the values of x. So we are given 5 values of x and 5 values of f of x. So obviously 5 pairs of x and y were given. And the question is find f of 9 using Lagranges. So whenever in the question the word comes Lagranges, compulsory you have to use Lagranges. 99% you are given the name of a method there. But by chance, if this word is not used, question is just evaluate f of 9, then you have to check whether you can use a Lagranges or you can use a forward or backward. So 9 lies between 7 and 11. Yes, it is in like a beginning of the data. So we can say forward also or Lagranges. But whether forward is applicable, to apply the forward interpolation formula, the first important condition is the values of xi should be equally spaced. So you'll observe 7 minus 5 is 2. 11 minus 7, 4. So you'll observe h is not constant. As h is not a constant, you cannot apply forward, say Newton's interpolation. Forward or backward, both also you cannot apply because h is not constant. To apply Newton's interpolation formulae, h class interval should be the constant. But in Lagrange's, that there is no condition on h, nothing is there, so you can solve it by Lagrange's now. So Lagrange's is very straightforward. So we have to start with the formula. Say fx is equal to like x minus a into x minus b into x minus c into a, okay, x minus d. We should check whether it should start with x minus b. I think x minus b, x minus c, x minus d, x minus e upon that b minus a into b minus c into b minus d. Sorry, b minus a, c minus a, d minus a, e minus a into f of a. That way. So just formula base. You'll observe this is like now why it is x is replaced by 9, because we want f of 9. So there is no question that find the interpolating polynomial. Unwantedly, don't waste your time to get that interpolating polynomial, because that simplification is too lengthy. First, you can write a formula if you want, like already I told here, that fx equal to, you can start this way also, like b minus a, sorry, x minus b, I have to say, my mistake. This is the formula, x minus b into x minus c into x minus d into x minus e divided by, now this is at a, so it is a minus b, a minus c, a minus d into a minus e into f of a, plus so on. So on means you have to write the term into up to plus f of a also. I hope you are getting. Any doubt?
No, sir.
So this is a step number 1. You should write this formula first and replace x by 9 everywhere, and a b c d you already have. This is a, just I'll write it. This value is a, this value is a b, this value is a c, this value is a d, and this value is e. This is a b c d e. So that about the 5 values we are given, and obviously the bottom values are like f of a to this f of b. So these are the notations mainly used in Lagranges, and you can just replace and do a calculation. So it is again a use of calculator. This matters here. So you should use a simple subtraction and multiplication and additions are there, but should not do the silly mistakes there. It's just a simple algebra, arithmetic. If anyone have a doubt, yes, you can ask. Can I move to the second question?
Yes, sir.
Okay. So second question is similar to the previous only. Use Lagrange's interpolation formula. Use Lagrange's interpolation formula to find out f of 10. It is just like f of 10. So again here only only difference is a, b, c, d are given. 4 values are given. So whenever you have to solve these questions, yes, you can start with giving the notations. You can start with this one is a, this one is a b, this one is c, and this one is d. So in a solution, we can start with by Lagrange's formula. By Lagrange's formula, this f of x equal to, yes, anyone? Tell me the formula first.
X minus b
Okay,
into
good.
x minus c
Correct.
into x minus d
Okay.
upon a minus b into a minus c into a minus d into f of a.
Very good. So similarly, the other terms comes. What will be the last term? Last term in the formula?
So x minus
A into x
a.
minus b into x minus c upon d minus a, d minus b, d minus c
Correct.
into f of d.
Correct. So there is some symmetry in the formula. So if you remember one term, remaining term similar, you can write it. And only the next step that is left, we want f of 10. So we replace x by 10. Replace x by 10. We everywhere. So on left hand side and RHS also. It is a 10 minus b now. 10 minus 6. Then 10 minus 9. Then 10 minus 11. Divided by this is a minus b now. So a is a 5, so it is a 5 minus 6, then 5 minus 9 into 5 minus 11 into f of a, and the f of a is a 12 there. Similarly, you have to write down all the terms there. I hope you are getting, and you have to do this calculation on calculator and you will get the answer. Any doubt up to here, anyone?
No, sir.
No, sir.
Remember, these examples are really a simple but calculative. Some student doesn't like this calculation and they make a silly mistakes there because they think, or some student take it as a too granted that this is very simple, I can do it. But when it comes in the exam, they don't have that much of a patience or focus and make the silly mistakes in calculation, get the wrong answer and lose their marks there. Okay. So the answer is 44 by 3 when you do this calculation, complete calculation. You can cross check it later on. Okay. So the last question then, one more question. Here is a third example on Lagranges. So the data, actually I started solution here. This is only the question. If y of 1 is minus 3, y of 3 is a 9, y of 4 is 30, y of 6, find the Lagrange's interpolating polynomial that takes these values. Okay. So this is the whatever the data given, that data I written in a tabular form. So you'll observe these are the values of x takes 1, 3, 4, 6. X takes the value 1, 3, 4 and 6, and these are fx minus 3, 9, 30, 132. So in our regular formula we'll give the notation now. This is a, this one is a b, this one is c, and this one is d. So again a, b, c, d are there. So we'll start with that fx is equal to say x minus b, x minus c, x minus d upon a minus b, a minus c, a minus d into f of a and plus so on there. And now what is the change? The change is, yes, we do not replace x there. because we want to find fx. The question is find interpolating polynomial. Find the interpolating polynomial or the polynomial that fits that data. That we have to find it first. Okay, that is mainly there. So we'll take fx equal to there. Okay, and we can replace the values of a, b, c, d, and f of a, f of b, f of c, f of d, and we get the answer then. So you can see here this is fx. So everything is replaced. Now the biggest task is to multiply these three brackets. Okay, that you have to do it one by one. Like first two you can multiply, then third bracket you can multiply. So this you can do it step by step there, and at the end you should get this as answer there. This is the cubic polynomial. You will get it as four pairs are given. This simplification is little lengthy. You have to do it. This multiplication of three brackets, that you have to do it in each term. But suppose if you do the multiplication of x minus 3 into x minus 4, so you have to see whether this same multiplication comes anywhere. Yeah, this x minus 3 into x minus 4 comes here also. So if you do this, you can replace here and here. Then you can take x minus 1 into x minus 6, which is x minus 1 into x minus 6 comes in middle two term. So that you can multiply first, and then remaining, then simplify. Okay, add cubic terms together, quadratic terms together, linear and constant. You will get the final answer. Got it? Any doubt?
Sir.
No one have the doubt here?
No, sir. No, sir.
No doubts. So let me sum up then. So if we see the recap of our first to ninth session, okay, we started with finding the roots of algebraic and this transcendental equation. Okay, so whenever to get this roots of the equation, we have the three methods there: bisection method, regular falsi, and Newton-Raphson. Okay, so with these three methods, just we are getting the roots of algebraic equation. These are approximate value of a root again, not exact. So that about the first article we completed. Then we started a finite differences. In finite differences, mainly we learned about the operators, the relation between the operator, okay, like forward, backward, shift operator, okay, and then we seen how to get the difference of this factorial polynomial. First, we converted given polynomial in factorial form, and then we take the differences like a derivative there. And lastly, we completed in last 2-3 session, we completed this interpolation. Now in interpolation, we have three parts there. Already we seen the three types of interpolation we seen here. One is a Newton's forward, or first there are mainly two parts. This is interpolation. Interpolation. Uh, H is a constant. H is a constant, and H not a constant. H is not constant. Obviously, when H is a constant, that means data is equally spaced. The difference between two successive values of X is a constant. Then we use Newton's interpolation. Newton's interpolation. And when H is not constant, we use a Lagrange's interpolation. We use a Lagrange's interpolation. Again, in Newton's interpolation, there are two parts. One is a forward, and another is a backward. The forward interpolation we preferred when we have to find or when we have to interpolate at the beginning of the data. At the beginning of the data. And if we have to interpolate the value of a function near the end of the data, we use a backward interpolation there. That's one. Is that clear? Now, any doubt in how to select which formula we should use there? But remember, in an exam, the first and most important thing that 99% of the question, the name of a method is given there. So you don't have to think. But if just the question is find f of 9 and x and y are given, now choice is with you. You have all the three methods. You should decide which method should be used depending on the data. If h is a constant, you should go for the Newton's. And if you have to interpolate at the beginning, use a forward. Interpolate near the end, backward. And lastly, if h is not a constant, then Lagranges. That's one. Any doubt here?
No, sir.
No, sir.